Going to get started on some probability today. Probability is the likeliness that an event will occur. So probability measures how likely something is to happen. Something with a probability of 0. Oh, I'm sorry. Start here. Probability is measured with this ratio. It's the number of positive events or outcomes, that is, events that meet the criteria we've set, divided by the total number of possible outcomes. So anything that could happen. If something's got a probability of 0, then it is impossible. It will never happen. And if something's got a probability of 1, then it is definitely going to happen. It's a definite. So anything in between measures its likeliness. So the closer something is to 0, the less likely it is to happen. And the closer an event's probability is to 1, the more likely it is to happen. You'll also see these numbers expressed as percents too, like 0% to 100%, or fractions or decimals. Okay, so let's get started. A number cube is rolled once. What is the probability of rolling an even number? Express the probability as a fraction and as a decimal. Okay, so probability is the number of successful or positive outcomes over the number of all possible outcomes. I like to start on the bottom, like the possible outcomes, bottom part of the fraction here. What can happen when we roll a die? We can get a 1, a 2, a 3, a 4, a 5, or a 6. Okay, and then we talk about the positive events. In this case, since we're talking about the probability of getting an even number, which of those possible outcomes are even numbers? 2, 4, and 6. So the probability of rolling an even number when you roll a number cube or a die is 3 out of 6. 3 even numbers, 1, 2, 3, out of 6 possible outcomes, 1, 2, 3, 4, 5, 6. And that could simplify to 1/2. So there's our fraction, or as a decimal, 0.5. Or you might say 50% chance. The number cube is rolled once. What are the odds of rolling a 6? Okay. Probability of rolling a 6. Well, the same 6 outcomes are possible. A 1, a 2, a 3, a 4, a 5, or a 6. Those are all the possible outcomes. I always start on the bottom of the fraction. And then how many of those outcomes are rolling a 6? Just 1. 6 is the only way you can roll a 6. So you have a 1 out of 6 chance of rolling a 6. We could express that as a decimal too, or as a percent, but we'll just leave it as a fraction. 1 out of 6 chance. If the chance of rain tomorrow is 20%, then is it more likely to rain or not rain? Well, let's start off by answering this question. What is the chance it will not rain tomorrow? Well, when it comes to weather, guys, only 2 things are possible. It's either going to rain or it's not going to rain. And you could say, well, no, it's going to hail, or no, it's going to snow. Well, I guess those things would all fall into the category of not rain for sake of this argument. So if the probability that it's going to rain is 20%, then the probability that it's not going to rain would be 100% minus 20%. Just 80%. So there's the probability that it's not going to rain. So that means it is more likely that it's not going to rain than it is going to rain, because 80% is higher than 20%. coin is flipped 3 times, what is the sample space of the experiment? Wow, this can get a little confusing here, but we have to come up with all the possible combinations of flipping a coin 3 times. For instance, we could get heads, then heads, then heads. Heads, heads, and tails. So there's all the possibilities if you get heads on the first 2 tosses. We could get heads, tails, heads, and heads, tails, tails. So there's all the possibilities if you get heads and then tails. We could get tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So the sample space of flipping a coin 3 times are these 8 outcomes. And we'll list them like this in set notation. Heads, 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 tails, so on and so forth. That is the sample space. Sample space is another phrase for all the possible outcomes. Sample space is all possible outcomes. Okay, so referring to the experiment in D, the last example we just did, what is the probability of getting heads exactly twice? What is the probability of not getting heads exactly twice? Okay, so let's take a look at that last one. Referring to the experiment in D, what's the probability of getting heads exactly twice? Looking at that other list, these are the 3 ways I can see to get heads exactly twice. Heads, heads, heads is 3 times, not exactly twice. So the probability of getting heads exactly twice would be 3 over 8. Okay. Sorry, writing this again apparently. And we also have to answer the second part of the question. What is the probability of not getting heads exactly twice? Well, if we're going to get heads 3 out of 8 times, then we're not going to get heads 5 out of 8 times. And I didn't include that in my solution, so I'll write it now. So the probability of, not heads exactly twice would equal 5 out of 8. I don't like writing my fractions like that, but we'll go ahead and write it like that for now. Next, Quinn runs a sandwich shop. Since she added turkey melt to the menu, 36 out of 120 customers have ordered the new sandwich. What's the probability that the next customer will order a turkey melt? Let's stop right there and answer that question. Well, since 36 out of the last 120 people have ordered a turkey melt, we're going to assume that rate will continue, and we'll just simplify that. 12 out of 40, and we can go further than that. How about 3 out of 10? So the probability that someone's going to come in and order a turkey melt is 3 out of every 10 people. Okay. If Quinn has 50 customers for lunch, about how many are likely to order a turkey melt? Well, all we have to do is take 3 out of every 10 of these 50 customers should order a turkey melt based on what's been happening in the past. Not a definite, but it's just a measure of likelihood. So what we'll do is we'll take the 50 customers and we'll multiply this by 3/10. And we know how to multiply fractions. And what we come up with is about 15 customers we might expect to buy a turkey melt. Okay, so there's a real world use of probability. If you've got some kind of pattern going, we can use that pattern to kind of predict the future using probability. It's not a definite, but usually works out okay. State whether the probabilities found in problems E and F are examples of theoretical probability or experimental probability. E was referring to that the probability of getting heads exactly twice. And we didn't actually flip the coins, so it's what should happen, but we didn't actually try it. So we would call that theoretical probability. In theory, this is what should happen. In F, where we're talking about the sandwich shop, we're actually using an experiment that we tried. 36 out of 120 people bought the turkey melt. So that's experimental probability. Theoretical probability is based on what should happen. Experimental probability is based on what did happen. What should happen, what did happen. Okay, so to break it down even simpler, theoretical probability of flipping heads on a coin is 1/2. There's one head on a coin. There's two possibilities on a coin 1/2 the time. But experimental probability of flipping heads on a coin, well, if I flip a coin twice, is it always going to have to show up heads twice? Or one out of those 2 times? No. It could come up heads and heads. And then the experimental probability would be 100%. Probably wouldn't want to use that experiment though. All right, so we'll talk more about that later, and we'll see more examples of those 2 things as well. See you tomorrow.